Hello guys. Today we're continuing with designing a kernel and dealing. Last time we made a thing, we just copied the entire guide. Honestly, it didn't do too bad. It got us to the point where stuff worked. However, there's a difference there's some things I've learned, okay? So let's go to bare bones. The regular one. Here, they use something terrible. Something absolutely fuck ass. Oh, what is this? Look at this shit. Why does it all have dots? Let me ask you a question. Why would you put dots in front of every fucking thing? Include weird things like at function. It's called not NASM. Okay, so here's two things. NASM documentation, PDF version. The net-wide assembler. Okay, there's that. And there's also GNU assembler, which we already knew these two things. Which I like this one for ARM stuff, but I don't know if I like this one anymore. After trying NASM and looking at how good the syntax is on the fucking assembly code, compared to compare the first one to the second one. Look how fuck-ass this shit is. Anyway, so we're gonna try again, but we're gonna do it my way. Okay? So, and here he declares them like this, using equals. Okay. I don't think you need to do define. I don't think that's a thing. I think you just do equals. That was something AI told me to do, was to put a % define. I don't know assembly, guys. I don't know what I'm fucking doing. So this is gonna go wrong. But I don't care. I'm having fun. We're just screwing around to learn something, so. Oh, right, and if you want to look good and proper, please do that. In fact, do a double tab. Do a double tab on all of them. Fuck that shit. I'm pretty sure this will work. So that will basically define each of them. Son of a... Oh my god. Please align it. And then you just set those equal to that. So we're just going to take the pieces of this and figure it out. The linker should stay the same as I have it, although I don't really know if that's correct. This code doesn't work from what I tried previously, and I'm probably going to rewrite all of this, because I don't really know if I want all of this. So for now, let's just scrap a lot of this code. Just put a for loop in there for now, because it can't really do anything, obviously. Clearly. I don't know why he wants to put the uint for magic and address in this thing, so, I mean, I guess that's important. Currently, where we're at is, NASM unable to open input file, boot.s, right, boot.asm. I changed it to asm because that's the standard, I think. Symbol equals is not defined before use. What do you mean it's not defined before use? This is i386 assembly. This is ELF32, right? Doesn't he compile using ELF? Oh, he just uses regular ELF. Okay. It's not declared. And then at the end he does a res b for stack size. Here's the where it doesn't have anything to do, it jumps back to CPU halt. Then he has section.bss, and this is something to do with the stack. So I guess if you look at assembly, people just jump all over the place. It's fucking, assembly's spaghetti code, I guess. People say jump bad, where you like have a label and you jump to it, but then you don't really look at your code and you go, or the assembly, and you go, well, it's basically just jumping around anyway. So here's extern for those. Global start. He puts the start up here. In the other one, they put the start down here. No, before that. But they put a lot of fucking comments in here, so it's hard to fucking read. Oh, start. Which is something that is in the linker. Basically, that's kind of important, because if you set start, you need an entry point, so the entry point is at start, so pretty much that's where the bootloader goes when it starts it. I'm guessing that we probably need these to be right after start. Now, because in the original one, start was at 0000 and then 0020. In this linker, he puts the number as for dot sections to be that. So that's his linker like setup. What he does with that is sets it to that. Which I actually did it backwards. I'm pretty dumb if I did it backwards. Anyway, I just assumed that you need to go to start, and it defaults to this if it can't find the entry point start, so. There's a bunch of other things. But yeah, this is a little more complicated. Here's something I didn't know yesterday, which was row data. It's actually just read-only data. So in your linker, in this linker, oh, I don't even declare row data. Or whatever the fuck that is. But it's in here somewhere. There should be a row data section. Or not. Who cares? I mean, we don't need row data. These are alignments. These basically tell it to align by this many bytes, I think. I think that, yeah, that's just 16 each time. Yeah, it's just 16 bytes, I guess. Something like that. This reserves, so res B reserves 16 kilobytes. Align 16. Section.bss. This is something to do with the stack. Checksum. DD is double. So double checksum. Double flags. If you do GNU assembler, you'll be using fucking ass, which is also going to make you use long, and I mean dot long, because everything starts with a fucking dot. It's bad enough we have .net, now we have fucking dot long. But anyway. Maybe I'm not using the assembler code correctly. No, wait, -F, so the format, yeah, format's correct. Maybe I put equals wrong. And yeah, he sets stack size to equal that. Here we put the stack size somewhere. No, we don't even do that. Equals. Equals. Equals is not defined. Why? Why is equals not defined? Global start. I don't actually know what global start really means. I'm pretty sure it just says that's where it starts at. Although there's a label start, which I'm assuming the linker goes to. Unless it enters at global. So, what do we do next? Bad B002. Yeah, I got that as well. So the magic is correct. There's also a CLI. I don't know what CLI does in this context. Equal not defined before use. But he does it here. I mean, I guess, I don't know. Yeah, we align 4. And then we have our multi-boot header, which is called section.multiboot. So put a space here so it looks better. Section.multiboot, then we have a multi-boot header label, which in turn allows him to call that from other portions of the program. Here they just do section.multiboot, and I don't think they ever jump back to multiboot. I don't know why you need to put a label on section.multiboot. Maybe it's so that bootloader finds it, but I am not sure. It's a good question for me to figure out the answer to. And he also extends ctors and ctors, start detours and end detours, which are not even something from the other program, but something he calls in here. So I'm guessing, let's just fucking get an AI overview of this. Give me the AI overview. What is this? Please explain. Son of a fucking asshole. And yes, you do need to not have a runtime, because if you don't have, so you have to import the runtime as well. If you don't, bad things happen. I guess it just isn't defined because it needs to have a global on it. I remember that the ARM assembly is way better. Global. We already declare a global though. Because those are not defined. And I guess you need to define it. Which... But yeah, it's kind of weird because of that. Boot ASM. Symbol equal not defined. Here we have EQU. Paste. x86 ASM. Equal sets a number in stone, sets a number until you change it later on. Okay, so it's like a constant basically. Oh, right, and you need a capital EQU, I guess? I mean, I don't know. Fucking... I don't understand why you wouldn't just have a one standard of a fucking assembly besides fucking Well, I mean, it makes sense to have different for architectures, but like, why not just have it, the assembler be better? I don't understand. Maybe I'm wrong. Maybe I'm like, I think what's going on is that whenever I do this, these aren't defined. Maybe they're defined by extern to start CTORs. But I don't know what these are, so I need to figure out what those are. I'm just gonna put this up here and see what we get. Entry points, a bunch of stuff from OS Dev. Initialization, compiler, collection, GCC internals. Which, yeah, GCC compiler is going to be different from NASM. However, we already have an example of what the NASM stuff looks like. I guess these are like stuff that I probably want. The code compiled includes constructors. Huge essay. I don't feel like reading that right now. But yeah, I think we need that, so we need to extern those. What was it? Like CTORs. I mean, honestly, I might as well just fucking paste that shit in there and get it done with. See if that fixes it. Yeah, no, I figured it wouldn't. Alright, take it back. We don't need that shit. So how does it get defined here, though? Because we know this code works. Is it defined lower on? That doesn't work. Please help me debug. Gordon, help me debug. Where is Gordon AI? Gordon Freeman AI. Oh, did I just paste and search? Is that EQW? Sorry, I can't English well. Massum and Tassum? Fucking hate assembly. You know, assembly cringe. Oh. Wait, really? Capital equals? Are you sure? Are you sure this isn't cringe? This is cringeanium. Fucking hate assembly. I hope we get to write more of it, though. That's what I needed to do. See, I'll hate it less once I learn it more. Ah, son of a bitch. Fuck. Yeah, we don't need those. That's what I did before. I did the fucking define. No. X86. As an instruction? That's fucking wrong. I'm not using it as an instruction at all. I am using it as it's supposed to be fucking used. Good God! Fucking ARM developer. Usage of EQU. EQ. I cannot pronounce this word at this time. Maybe I didn't format it correctly. EQ. Like, it needs to be EQU. But, I'm guessing I don't have enough tabs in there. We all know tabs make the difference. Get this shit off my fucking screen, bro. What the fucking Reddity? What the Reddity? What am I doing? Brain cells are failing. Module align. You know what it is? This is a line. It's a keyword. It's an instruction. Module align. Now, module align can be called there. You know what that means? It means it makes sense now. We did it. Alright, watch this. Ah! See, that was the fucking problem the whole time. Now, LDC that, and then LD the two of them together, create an unholy fucking bond, and then Kimu them. Qimu system. Huh? Oh, you know what it is? When I do my LD. When I do LD, let's do it as, I know we can get kernel.bin to work, probably. Maybe it needs a .bin. Load it. Qimu system I36, error loading uncompressed kernel without PVH ELF node. I'm guessing, because it works better when I did MELF I36. This needs to be the actual 32. See, if I do that, then I do my... You know what it could be? It could also be that I have LDC and I'm putting it right in there. Because what I'm trying to do is I'm trying to avoid using fucking GDC on this shit. I don't want to use GDC, I want to use LDC. LDC is for high-speed people, so we'll use LDC so we can be fast people. And then go ahead and NAS them. And then do it again. Qimu system. Alright, so cool. Wait. Dutch bin. Holy son of a... Fucking... Oh, right. I also need to do tabs to fix this shit. Or, what the fuck happened to my formatting? What the fuck happened to my form... Guys, I just want to let you all know, if you find these videos enjoyable, then you're a nerd. Lol. Alright, so PVH ELF note. I don't know what that means, so I'm just gonna shove it in my search engine and see if it poops out a good result. PVH specification. That means a kernel is loaded and directly launched by Zen. Refers to specific format and metadata requirements for Linux kernel binaries that allow them to boot using PVH, paravirtualized hardware protocol, as in the Zen hypervisor. Alright, well then let's just go ahead and dash machine. And then say... type equals PC. I don't think that's actually going to do anything for us. Let's go back. What the son of a bitch? PVH ELF node. Oh wait, maybe I actually got it to work. Alright, so let's add that into the command. Alright, go ahead and do this, and then shove a Control-Shift-V in there. Nice. Alright, yeah, I figured that was gonna be the case. Yeah, that's not a problem. That shouldn't be a problem because we followed the guide yesterday on this one. It should have been correct. Now I'm guessing ELF note. What is that actually? Maybe it just wants a regular ELF for my NASM instead of ELF 32 like a fucking jackass. Maybe I should stop being a jackass and just put the correct answers. I think that's the correct shit. Yeah, who cares about that load segment with RWX permissions? What's it gonna do? Hurt me? Alright, let's see. Maybe it is this load segment with RWX permissions. So let's look. Load. Maybe it's extern. I don't know what a load segment with I think read writes permissions. It needs row data. Scroll down. So in here, they define row data for the .text section. They link row data for .text. So where's .text at? Pretty much right up in here. .text has row data. Row data. Alright, so then we need to define that for section.multiboot. We need to have row data for that. .data. Do we have a .data section then? We don't have a .data section in my original kernel boot ASM, do we? Does boot ASM have that? I don't even think we have a data section for this. Why the fuck did I... Also, is linker D formatted for fucking... Alright, so we have multi-boot and .text. So there's section.text, which is going to need that row data, which we already discussed in the fucking linker down here. They put row data for .text. I'm guessing this is important to get rid of that RWX, which occurs when you try to do LD to create the I386. Are we compiling this correctly? I think we are. With GDC, you just compile to like a GDC I386, and then you're good. I think that's something interesting though, because I don't think they included data section in their linker on this one. Or actually they do. And they also include a line for those, which I don't include. I mean, when I got this to boot earlier, it just booted to a black screen in QEMU. So that is pretty interesting. But yes, we'll go ahead and define or link this with a fucking thing. Row data. Text block, and then also point to row data. Oh, this is for .row data. So what does he put as row data? It's under text, I think. Row data. Oh, where's row data hiding at? Read-only data, by the way. Section.bss aligns 32. Oh, that would be like to get it into the 32-bit mode, I think. What is common? Where's that at? This is what I get by just... I don't have a section for common, I don't think. But we should be able to load into 32-bit mode. So this one goes to section.bss, which is... Or, no, that defines section BSS or something, or initializes that. I don't know what the words are. It's assembly. It's fucking cringe. I hate assembly. Because I don't know assembly. That's why I hate it. And then, that's, yeah, 32. Stack res b is stack size. Oh, okay. So that's just the stack. And then res b is what they're reserving. Stack size. Or stack size is what they're reserving. So stack size is 16 kilobytes. Okay. Oh, yeah. Call kmain. That calls the kernel. Line 32. Test. I think there's a lot I'm missing or not understanding yet. You just need the boot header and then you're pretty much good. Although there is a little bit more. So if you look at the C1, the C1 has a dot size start, and that's another reserve B. So I'm pretty sure you would do dot section, call it BSS, which I think we have it right here. Yes. This one aligns 16. Stack immediately follows it, and stack does. Also, we can space these over to make it look more correct, even though it's probably super wrong. But underscore start is actually supposed to be regular start. That's another thing that's important to getting it to work. And then I think that's pretty much it. This is a label under start, although I don't know why I have that there. I guess it's to jump to dot halt to loop. So that would be how you would do that, I guess. So let's do NASM again. NASM, then let's do LDC, then let's try to LD. Alright, so now we have, cannot find, alright, that's because I changed it from underscore start to regular start. Dot 2, actually, I've been told in the OS dev guide here for the regular C variant is a important thing. Where's their linker at? Go all the way down to the bottom. So linker, if we go to linker, their linker says that, oh, dot 2 M. That's what we're missing. So when we do that, that will fix everything. Oh, cannot find entry point symbol start. Defaulting to 0, 2, 0, 0. Has a load segment with RWX permissions. I don't know how to fix that yet. I'm just gonna search it now, just because I don't really know what I'm doing with that. Oh, whoa, it didn't copy? God damn, I'm allergic to assembly. Oh, fuck. Me being the biggest assembly hater. Oh, it's like I hate GL, I hate assembly. See what they have to say. Seems LD has been updated. The problem is in copy table, and these are used for initializing data and BSS segments. Actually, only data because BSS is initialized by C runtime, but both has the same concept. These sections do not contain anything other than static data created by the linker, like below. So that means the linker is doing something with these. So like dot text gets these linked in. It's like static data for them. Common and BSS. And so common must be weird. It must be like something that does dumb stuff. Let's look at where common's at. They have a common. They do a colon for a line 30 or 4K. So probably 4 kilobytes. And then it creates common, which I think might be defined in the original code for the C stuff. There should be a common section in here. Common. Potentially they declare common in this, and then they extern to that. I don't think they do, though. I don't see an extern in their original assembly. Because I don't even know what a fucking extern would look like in a gas assembly. So that's great. AKA shooty ass assembly. Let's just do a key move system. Okay. Does not want to do it because error loading with PVHELF node. In the original guide, we saw that, well, oh, actually, what is a PVHELF note even? How do you create a PVHELF note? Let's just get rid of this. What happens if I get rid of that? What is it going to do? Actually, what does this mean? I'm curious. Like, what does common in this case mean? They don't explain it in here, I don't think. Common, read, write data, uninitialized, and stack. So what? Read, write data, uninitialized, and stack. So what? This is just like, where's common at in their code for the assembly section? Common must be in their assembly, I'm guessing. If it wasn't in their C, it's probably in here. Like section common or something. I don't know. No, I don't think so. Okay, back down. So I guess we just can get rid of common and I think it will work. It's a lot of I guess, because I'm not sure actually. This is what we're gonna do. I think we can just do LD and it will attempt to do it. So yeah, I can't find the starting point. I know exactly why that happens. That's because I didn't specify start differently. So if I want to do this correctly, you would do like underscore start. However, maybe I should do start underscore would be better, because that is a better way of specifying that it's different from the global start. Where's that at? Global? Yeah, there's a global underscore start. Maybe the global underscore start has to be the same as start. Although I don't like that it's a fucking underscore there, so we'll put a global start and see if that works better. And then redo the NASM. Alright, now maybe it could also be the LDC. Like when I use LDC versus GDC, that probably screws a bunch of shit up. Although I think no GC and that should be good. NASM -F and then LD and then Kimu. Will it work now? Without a PVH note. So in their C code, what do they do? Do they have like a thing that they need to, if a IX86 ELF compiler So maybe I'm not compiling it to, although at --m32 would specify the, let's see, LDC to compile as I3 or I186, I386. Yeah, I386. LDC. Oh, you know why? Because we're not compiling to maybe this. I don't know. Let's just keep going. Actually, why am I using LDC2 though? Honestly. I mean, also, we are doing --m. Let's just find the LDC2 manual. That's what I need. User manual. Light-driven LDC and LDC tool. I mean, that's ARM though. I don't need ARM. I am not compiling for ARM. x86. LLVM decompiler. So here's all the information we need on it. I'll keep that ARM developers page open too, because we will eventually work with ARM, it's just not now. This weekend we'll do some of that. Write documentation files. OC do not link. Did I include a -c in here? Yes. I included a -c for whatever fucking reason. Oh, wait. Oh, okay. Is the same as output file. What do you mean it's the same as output file? Maybe it does need the -c in there. That's probably part of the reason why. -c. Oh wait, yeah, I guess that would also be true. Linker. That usually with DMD it defaulted to the LD linker, which I honestly prefer that one. Do not link. Code manual. Allow deprecated language features. Debug. Depths. Disable. Enable invariants. Can I do cross compile? 32-bit target, yes, that's part of it. We don't have we have a dash at the end. So I thought it was dash for whatever reason, but no, it's just a regular. That's NASM, and then try the linking, and then try the QEMU, and then it fails. All right, so you'd actually get a cross compiler targets. Dash no runtime. We don't need GC though. GC is, I think, done at compile time. Yeah, that should be good. No runtime. Sort timers? Yeah, that's weird. No runtime. Why would this be in here if it's no library for linking implicitly? No assembler is to disallow the use of inline, obviously. Why is that important? Because you can do inline 86, so if you didn't want to have it inline 86 for some reason, and you had it built in and you just didn't want to compile the inline 86, I guess that would be the case. Write native assembly, write native object. So you can do a -S to get assembly out. That's pretty cool. LLVM. By the way, this is the LLVM toolchain for it. It's for dealing. This is the fastest toolchain you can use. Although I think GNU compiler would be emit from 86 back up would be better. And they're pretty much the same as DMD, so they're pretty interchangeable here. Although, for some reason, oh shit. For some reason, whenever it calls -M32. Since I'm running an x86_64 system, it's probably partially that. It's probably part of our issue. It wants to say short timers, but that's not something we need. What the fuck do we need then? We need not that. We need something else. Dash no runtime. You can't really do the runtime. Architecture to generate code. So dash march. Dash march. And then do ldc-march, so it's passed to the fuck you, Brave browser, fuck you. Just pass to that. Very useful. Let me go back to the manual pages. Good luck, bro. Yeah, I'm failing so bad right now. Link time optimization, debug. We had it working yesterday. We followed the D bare bones tutorial, and what we got was like, it gets to the boot and it gets stuck. We followed that and got stuck at the boot. So today we're just gonna do our own shit. Since I don't really want to follow a tutorial, I want to try to apply what I learned from yesterday. I guess just give that a shot. It doesn't want to do. Doesn't like that, but it does like no GC. I mean, I don't think that matters too much. Maybe -C, invalid dash version. Okay. LDC2 dash version. All right, here we go. x86. Cool. Let's do that. So then put in x86, and that cannot be used together, and M64. Yeah, I think that makes sense, because it would be a 32-bit, and if you just say 32-bit, then it will just try to compile your own architecture, but with a 32-bit. Now we can do NASM, do that, and then we can do LD. Still has that. Hopefully it will just boot though. I really want to see it just get into the boot. Okay, never mind. PVH ELF note thing, and then all of the fails of this. Has load segment with RWX permissions. But I think that could just be that we didn't disable the runtime. So let's try LDC2 dash help. I can't understand English, but I'm excited. Oh, okay. Okay. There's only no ASM and no GC. Wow, this is not gonna work then. No wonder it isn't working very well. Alright, so LDC2. What version do I have? Maybe it's just that this is an older version of it and it had no runtime. I guess we would do -no GC. I think the GC is a part of the runtime. That means we'll need to use mlocate for everything. Target a specific CPU. So you can like optimize for that. Write LLVM bitcode. I think it's just that we're not using GDC. Let's try, I have it written out, but it's just, this should work really well. Okay. So you do GDC-F no runtime. Boom. Then you do -M32 -C kernel.main.o and or no, yes, that would be the out. Or no, that's the input. And then kernel.main.o, but you need to specify that with a -o, and then you want a -g, which I don't know what the -g does, but we'll check. This needs to be right next to this. So -f no runtime. fd no d runtime. Yes, fd runtime. Oh, it's f no d runtime. I have it written down in my notes, and then it's, yeah, I forgot to put the dash. Okay, and then that's done, and we can do nasm, and then we can ld. Still has a load segment with RWX permissions. Don't understand. What the? Alright, QEMU system. Yeah, with a P, what the fucking shit. I think it's just linker.d, because you do this and it has a, somewhere in here there's a fucking thing. Copy this. Copy this. Paste it in the chop. Go. Yes, figure out. Oh, don't just fucking put all that in there. It's gonna be like, oh yeah. Help. I think we'll find a bunch of stack exchanges with that one. Huh. Oh. Really? So, creating a security vulnerability. Let's see what they have to say here. Oh, okay. Oh, hey, look at this. Read ELF. Cool, we just learned something. Read ELF. Ooh, -L my underscore file tab. I think we just want to read kernel.bin program headers load. So there's two loads, and GNU stack, which has RWE, RW, and RW. There are 3 program headers starting at offset 52. Damn, this is a cool tool I didn't know about. I'm glad I went to Stack Exchange instead of going to AI like we usually do. in previous episodes, going to AI was a fucking bad idea. You don't learn anything that way. Here we have learned about a new tool called read ELF. Read ELF. And then, yeah. Dash L LD output. Alright, so that does two things. There's two things going on in this that have, they've been aligned to there. That's load. That's load. One has RWE and one doesn't. I don't know what those are, though. Load, 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 load. I just ran into the same issue. I just wrote different code. ST officially recommends the solution where you simply add read-only for each section that goes into flash memory. Pre-init array read-only. Okay. So here we have these that are all set to this. I'm guessing. Okay, here's a stack. Here's this. Okay. Now let's re-put common in there because that's important. So uninitialized common, I think, is important. So these get loaded. The first one is RWE. The second one is RW. Why is this important? Because it is. Although I think they have different addresses, but their offset is the same. I don't know what that means exactly, but if their line is probably the same position, I have to guess that it's probably that. If we go in here, we align 4, we do our dot section or section.bss, and we also have resb. Then we also go down, stack top, section.text. So section.text starts here. It has RE, I think. So I guess it has to do with not having a row data thing, read-only data, which we don't have. This one I don't think specifies read-only data, but then the original, the one that I followed to make the linker and all of this, the assembly stuff, this one is also written in gas, so I don't really like gas. Gas is a pain in the ass, that's what I like to say. Unless you just did gas for the whole thing and followed it exactly to the T, but I am not doing that. Stack bottom, colon dot, and then that just takes you to the bottom. Hold on. So I do section.bss, then I do my stack bottom, and then I go to my stack top. Or no, I have a label stack top right here. Cool, and under stack top is these. There's also a thing called CLI. I don't know why that's in there, if that's specifically to gas or not. If the system has nothing more to do, put the computer into an infinite loop to do that. Disable interrupts with CLI, clear interrupt, and enable E-flags. Interrupts enable in E-flags. Okay. They are already disabled by the bootloader, so this is not needed. Mind that you might later enable interrupts and return from kernel main, which is sort of nonsensical to do that, or to do. Wait for the next interrupt, drive, and wait, and halt until halt instruction, since they are disabled. This will lock up the computer. Jump to halt instruction. If it ever wakes up due to a non-maskable interrupt occurring or due to the system management, So basically it just tells the thing to fucking wait until you do something. But why? How does that work? So like, what's the next thing you do after this? Call kernel underscore main, which we do, and then it does this shit. So kernel main probably delivers like, or sends interrupts to this. I don't know, but that doesn't matter. I think what it is that we disable the flags. When we try to load it with QEMU, it gets pretty close. It actually does load it, but we disable the flags. So let's go up, QEMU system, out, and PVH ELF note. If we remove this, what are the odds that fixes it? Then we go back and do our NASA, do my GDC again just to have it, and then do my LD, and then do my QEMU system. Okay, doesn't work. That's cool. Good to know. I can keep that in. It still doesn't have the PVH note, and it still has that. Let's go ahead and do our read ELF again, which returns all of this. So we have load, and that has these. Align. I guess, what did it say? Has a load segment with RWX permissions, which I'm guessing this one has RWX. Read, write, and E. And then if we go to here, maybe one of these needs to be read-only. If we go to this linker design, you will see that when they specify, yes, they put a row data align after they do this. So dot text is followed by dot row data. However, then there's data align. So this probably disables that. That's what I think, is when you do read-only data, it changes that its permissions to be the correct ones. Then do... Technically, you can do the other thing, but anyway. 0x110, which is, yeah, the address. But I could also just put 4K and it should be on the right spot. I mean, why not? And it's gonna do... Also, I'm not a fan of how the people who wrote the C bare bones did it, because I like to put my shit like D-line. What am I fucking doing? Row data. And it's a thing that does that. Alright, cool. I've learned something today. Now, what is in row data exactly? Is that a thing in their assembly code? Scrolling through. I don't see anything called row data in here, just at a glance. So I think it's good. NASM, GDC, and then LD. Syntax error. On the line 12. Dot row data. I think it's just that this is not 0x0. Fucking 1 or yeah, 0x 1/1000. Oh, but I also forgot the colon. Then do that. Now, let's try it again. Has a load segment with RWX permissions. That's fine. But that's what I'm trying to fix, is that. Oh. Fun. Yeah, fun. We did 0x100. Put a row data align. I think it needs to correspond to a similar thing in the assembly though. There should be a section with .row data. Control F, row data. Oh, it's only here. Oh, wait, they put a pointer under text. So we'll put that under the multi-boot header as well. Which should give us what we're looking for. And then also .row data. Guessing that's how that will work. Alright, try it again. From NASM. Then we don't really need a GDC, I'm just doing it to keep it up at the top so I don't have to rewrite all of that shit. Alright. Uncompressed kernel without a PVH ELF node. Did I do -G at the end of my GDC? Yes, I did. Cool. Fun, 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 fun. Could be that it doesn't have any kind of like... There's also a pointer to comment here. Alright, well... This guy doesn't really have too much information besides that. So... I'm gonna go ahead and just shove this into the fucking search engine and see if this pops up any results. What we do know is that the other stuff. I know it's not. What exactly is PVH protocol? And what changed so drastically since... Wow! Nobody gave him an answer, bro. They just gave him upvotes. Bro, he got upvotes, but nobody answered him, bro. What the fuck? PVH VM documentations? Maybe it's something to do with VM. Man, like, browsing for this information. Ah, here we go. OS Dev has the answers. Where'd the AI go, bro? The AI was at the top always. Now it's just OS Dev is at the top? Good, though. OS Dev is good. -F ELF. Oh, maybe that's it. We'll try NASM-ELF32. GDC. LD. Okay, fine. And then... Cringe. God damn it. Use LD to link them. It's either make it or have a multi-boot header. I mean, what does he do? He has a multi-boot header. Let's put that in there. Let's go to kernel main. Or, no, here. Let's put in a fucking multi-boot header. Maybe that's it. Because at the end of the day, I think what it is it's not discovering the multi-boot header because we just don't have the header on there. And I think it might be looking for that. So if it's looking for multi-boot header, that's important. And then here's stack size. He declares stack size here, right? That's a constant. It's equal to that. So if that's equal to that, then when he goes down in the loop, or in the system, he puts stack size plus stack, and that's the start of it. It pushes EAX, which are, I think, registers or something. Maybe something else. I don't really know exactly. Alright, NASM, GDC, LD, and then QEMU. Okay. Well, we failed again. Why though? Fucking... Oh, yeah. Let's make a new one and just test if his stuff works. Create that. Alright, so we're gonna do everything exactly as he says to do it. Like 100% instead of doing some of this on my own. We're just gonna copy and paste every single piece of this. New, we're gonna just paste it in here. Save as, we're gonna go back and put it in the kernel D example, and then call it, what does he call his start.asm? cd /tab. Look at those delimiters right there, bro. Perfect. Alright, so now we have our kernel d.example. And then we're just going to follow exactly what he says to do. Because I'm curious whether it's that I've mixed two things, and then I wonder what exactly the outcome of doing things exactly the same yields us. I wonder if it's also that yesterday I kind of just went off and did my own shit. Because that could have potentially been part of it as well. Alright, we're going to make a new one. Paste. See if this thing even works on its own. Because I was wondering if, like, the entire boot thing didn't work. And then call this module.kernel main, or just call it kernel main.d is what he calls it. Which is also what I called it when I was working on mine for a little bit. Just because I wanted to stick with that naming convention, it sounds good. Maybe I'm not doing M32 when I do my GDC, but I think I was. So we tried 2 compilers, then now we have to do the linker. Let's do this. Maybe I'm doing the linking part wrong. That could potentially be it too. There's a lot of points of failure here to think of. Then go back here. Oh, no, that's wrong. Linker.ld. We'll see if, like, this even... Because yesterday, we did almost the same shit. Although I think I made a few mistakes. We just followed along with this guide, and then I was like, yeah. Made a few mistakes, I think. And then it just didn't work very well. So that's what we're doing today. We're just trying to figure out how to do it. Alright, so that's good. Now all I have to do is this. And then that. Ooh, that looks weird compared to what I do. Actually, no, that doesn't. Paste. And then he also does this. Oh, so it does work. Wow, okay, so that's interesting. I don't know what a lot of this does, though. I still need to figure out a lot. I mean, so with my stuff, then, how do I get mine to work? I don't understand. Because I've also mixed two different things, so I've been using this to design mine. And then this uses gas, which is not cool. Gas is not cool. NASM cool, I think. You know what it is? I don't think I put entry on mine. Oh, I did. But entry isn't correct. That's been the problem the whole time. Let's go back and redo my NASM. Oh, cd / NASM. Alright, let's try that again. Boom. Is that mine? I think that is. I mean, it will work the same as mine. Even if it wasn't. That's not mine. Is it? Actually, that it is. That also will work. No. Because mine is called boot.o. Oh, wait. When he does LD, he goes kernel.bin start.o. So boot.o comes before your D code, by the way. I think that's important. So probably is important. So that. But in boot ASM, did I say start is underscore? No. Maybe it's start underscore. Well, why didn't it? So it doesn't find it unless it's fucking unique. Because then it's like global start. Maybe if I do start, and that will give us the answer. I think it's something wrong with the linker. Let's get rid of row data. We don't need that. Because what I think we need is to just put read only. I think that's gotta be capitals though. We'll see if that throws an exception. Redo the NASM, and then I'm just gonna try to link. Okay, and then do Kimu. Without ELF note still. What is the PVH ELF note? So it's either make it ELF or have a... Oh, wait. Use -f ELF. How am I doing NASM then? -f ELF 32. Maybe it should just be -f ELF. But we want it to be 32 bits. When I did NASM in the example, ELF is just literally ELF. So then that GDC LD Kimu without PVH ELF note. So there's a note somewhere in the original design, I think maybe, or like something that specifies what are these for. Like, I don't have these in mine. What do I need them? Because those work. Anyway, I don't really have the answers, and I'm out of time for today, so I'll figure it out more on my own. I'll do my research in my free time, so if I have free time today, I'll do that. Well, I'll see you all next time, and goodbye. It's been pretty good.